Hi guys, I miss you so much. I hope you are all doing well. I hope that your families are all doing well, that you're all healthy, that you're staying home unless you absolutely have to go to work, which if you have to, I get it. But otherwise, please be like me and go crazy at home. So the purpose of today's video is to talk about some inverses. So if I were to ask you, what is the inverse of um, addition? So the inverse of addition, yeah, you're going to say it's subtraction. And if I say what's the inverse of multiplication, yeah, you're going to say it's division. So typically we think that inverses mean that they're the opposite of one another. But that's not always the case mathematically. So what happens is, when we're looking at a graph, so you're welcome to follow along with this so you can see the actions in place or not. But so what's happening when we think about inverses, if I were to say y equals 3x, to figure out what the inverse of this is, what I'm going to do is I'm going to switch these two variables. So I'm going to put it as x equals 3y. And you're like, oh, that's easy. Well, then we have to put it into a format that we can graph. Well, or we could just use our Desmos graphing calculator. So let's look at what's the difference between the graphs when we have y equals 3x and x equals 3y. So if you go to your Desmos graphing calculator, you could do just do an untitled graph, y equals 3x. We could see this dandy line. And then we're going to do a new one, which, remember, all we did was flip-flop the x and the y. So we could do x equals 3y. Huh. Now, let's make this a little bit more complicated. Let's do plus 7. And then, oh wait, we just have to add our plus 7. What happens if we change these to negatives? They're very similar shapes. So how do they relate to one another? Let's try different kinds. So let's do y equals x, and then let's do some exponents. Squared. Oh, we've done this one for a little bit. So again, when we're thinking about inverses, what do? We simply flip-flop. So x equals y squared. Now that's interesting. That kind of helped us see what's happening to this graph. It basically rotates 90 degrees. But does it? Let's add a few more things to it to see if that kind of changes what's happening in our graph. What's really happening here is not that it's rotating 90 degrees, because if it were rotating 90 degrees, this graph would be up here. What's happening is it's flipping across this invisible line, and the invisible line is y equals x. And you can see every single one of these points is the same distance away from it. In fact, if I were to fold this graph on top of itself. Along that y equals x line, both of these two graphs would lay on top of one another. So this is true. We're going to keep this inverse line for just about any two inverse functions. So if we go to y equals 3x to the third plus arrow over plus 2 x squared minus 5. And again, remember, all we do is flip-flop our x's and our y's. So we would have 3 y to the third, arrow over, plus 2 y squared minus 5. And you can see it doesn't matter, and I can kind of hide this over. It doesn't matter what our equation is. It flip-flopped across this red line here, the y equals x, and it becomes a mirror image. That's the true nature of an inverse relationship. So if we're thinking about it this way, you might have to ask yourself, well, if I know that the inverse of addition is subtraction, and I know the inverse of multiplication is division, and I know that the inverse of squaring a number is doing the square root, how do I find the inverse of raising something to a power that I don't know? So for example, how do I change it to y equals 2 to the x? I have to know what's the inverse operation of that in order to determine it. Well, we can't. Yes, we can. There is, and it's not square root, because square root would be when there's a 2 for that x, but we don't know what that number is. So if I put in x equals 2 to the y, Interestingly, there is a name for that function, however, and it comes up the same way. So if I click on this functions button and I go to miscellaneous, so it starts out with trig, then stats, then distributions. If I go to miscellaneous, I can go to this log A. And a log means logarithm, and a logarithm is actually the inverse operation of raising a power. So the log of, now, 2 is our base in this previous example. So log base 2 of x. So y equals, come on, equals, y equals. And you can see the purple line lays directly on top of the green line. So you can see that these two things are the exact same thing, which means that the inverse of this is this. that's all I wanted to talk about today. Is what is the inverse of an exponential function? It is a logarithm. And how do we know that it is? We can see it graphically because we can see it along this image that anything that is flipped across y equals x is considered an inverse relationship. We can see it mathematically. So when we switched our x and our y, they are inverses as well. So answer some questions in your quiz, and I miss you all, and I love you all, and I hope you are well. And if you have any questions, please reach out.